Hello, and welcome back to another IB Math Speedrun with me, Vince. And today we're going to be continuing with quadratic functions and, well, yeah, stuff about them. So let's jump right in. So what we're going to discuss in this speedrun is something called the discriminants. So we went over the quadratic formula last speedrun for AC over 2A. And, well, the discriminant is the expression that tells us how many roots, or the nature of the roots in the equation. And we can tell by this over here, which is b squared minus 4ac. This tells us what the roots look like in the equation. So, why do they tell us? Well, this tells us really how many real roots there are. So we have three cases. If b squared minus 4ac is greater than 0, then there are two roots. Or actually, not even that, if it's just inside, not the square root. Because square root b squared minus 4ac, if it's greater than 0, well, if b squared minus 4ac is greater than 0, then the square root of it, well, there will be two possible values, so there will be two real roots. If b squared minus 4ac equals 0, well, then the square root of it, well, it will just be 0, so there will only be one real root. And finally, if b squared minus 4ac is less than 0, then there will be 0 real roots, since you cannot get real values for the square root of a negative number. So normally we denote the discriminant by the Greek letter, I think it's phi. Delta. So delta, just remember that delta is equal to b squared minus 4ac. Yeah. So yeah, that's pretty much it, and now we can jump into some problems. So we have our first problem is, without solving the equations, we want to determine the nature of the roots. I'm going to do the even problems because, usually they're harder. So we have x squared plus x plus 2 is equal to 0, and we need to determine the nature of its roots. How do we do that? Well, we need to look at b squared minus 4ac. So b squared in this case is 1 minus 4ac, which is 4 times 2 times negative 4 times 2 times 1, which is negative 8. So 1 minus 8 is clearly less than 0, so this will have no real roots. So the curve will look, in general, yeah, the curve will probably look something like this, where the never just touches the x-axis, and so there are no real roots. So the next equation, we have 5x squared plus the root 3x plus 2 is equal to 0. So looking at the discriminant again, b squared, which is 3, minus 4ac, which is 4 times 5 times 2, so minus 40, is also clearly less than 0. So again, this has no real roots. And yeah, that should be it. So finally, we have our last equation, 2.25x squared plus 49 is equal to 21x. So we need to bring this over to that side, so we have 2.25x squared minus 21x plus 49 is equal to 0. And so we have b squared, which is 21 squared, so 441, minus 4ac, so that's minus 4 times 49 times 2.25, which I have no idea. Oh, it happens to also be 441. I guess I should have expected that. So 441 minus 441 is clearly equal to 0, so this will have one real root. And just like an interesting thing to note is that for all equations that have one real root, you can just express them in the form like this. It's just going to be some linear expression squared is equal to the final answer. So in this case, it would probably be something like 1.125x plus 7. Is that even correct? 1.125 times 7 times 2. Did I make a mistake? Did I make a mistake when multiplying it? I might have made a mistake. So, oh, lagging. 2.25 should be 1.125 plus 7. Oh, minus 7. But that shouldn't have made a difference. Oh, wait, no, sorry, this is wrong. This should be the square root of 2.25, not 2.25 over 2. So this would be 2.25 square root is 1.5, so we would have 1.5x minus 7 squared, which is equal to this. So yeah, you can see we only have one root at all. Okay, next we need to find the values of the given parameter for which the equation has two distinct real roots, one real repeated root, and no real roots. Okay, so what do they mean? Well, the equation looks something like this. 4x equals 3x, 4x squared equals 3x plus 4 minus t. So we need to find values of t for where there are two real roots, where there are one real root, and where there are no real roots. So let's rearrange this and find a discriminant. This would be 4x squared plus minus 3x plus t minus 4. So get the discriminant would be, again, negative b squared, so b squared is 9 minus 4ac, so that's minus 4 times 4, so that's 16 times t minus 4. So in the case that there are two real roots, this has to be greater than 0. So we have 9 is greater than 16 times t minus 4. In other words, 9 is greater than 16t minus 64. And so we have, what is this? This is 73 is greater than 16t, so t is less than 73. T is less than 73 divided by 16. Okay. So if we go up, we have t is less than 73 divided by 16. Okay, so what if there's only one real root? In this case, 9 is equal to 16 times t minus 4. Since 9 minus 16t minus 4 must equal 0, so t must be equal to 73 over 16. And finally, if there are no real roots, t must be greater than 73 over 16. I hope you can see that. But in case you don't realize, let's just quickly show it. 9 minus 16t minus 4 has to be less than 0. So 9 has to be less than 16 times t minus 4. And so we have 9 is less than 16t minus 64. So we have 73 over 16 is less than t. Yeah. That should be it. So, that was all for this speed run. I hope you learned about the discriminant, and I hope to catch you in the next one. See you then.